Hi everyone, this is Darren here, and today's topic is addition of algebraic fractions. So without further ado, here's my first example. So suppose we have x over 4 plus 3x over 2. How do we approach this question? You see, it's a bit difficult because both of them have a different denominator. So we can't just go ahead and straight away add them up. But can we change the denominators such that they are the same? Yes, we could. And that is the first important step when we are approaching these types of questions. So we see that 2 here and 4 here are the denominators. So we have to ask ourselves, what is the lowest common multiple? So in this case, the lowest common multiple of 2 and 4 is just 4. So we know that I can actually change this part here to something over 4. And that is what we should go about to do. So let me go about doing that now. So this becomes x over 4 plus the denominator becomes 4. So what do? I use 2 multiplied by 2 to get me 4. And if I multiply the denominator by 2, I must multiply the numerator by 2. Hence, 2 times 3x gives me 6x. Therefore, this will just be x over 4 plus 6x over 4. This gives me 7x over 4. And we have our answer. Alright, so moving on, something more, maybe slightly more complicated. We have a second example here. Suppose we have x plus 1 over 3 plus x over 4. See, now we have our x plus 1 here. But again, hold on. The key to these types of questions is always to make the denominator the same. So we go about thinking how to do that first, and we do not worry about this x plus 1. Okay, so let's see. I'm going to change this to, what do I change this to? Right? If I multiply this by 2, this becomes 6 and 4. We still don't have a common denominator. So what we have to do is think about the LCM. So the LCM for these two numbers is just the number 12. So therefore, how do I get 3? How do I make 3 to the number 12? Well, I'll multiply it by 4. Hence, I'll just multiply the denominator here by 4 and the numerator here by 4. This gives me over 12 4x, because x times 4 gives me 4x, and 1 times 4 giving me 4. And then, over here, to get our target, which is 12, we need to multiply by, hopefully you said 3. So, okay, x times 3 gives me 3x, and 4 times 3 gives me 12. So therefore, we have now converted the terms here into the same denominator. So we are really close to solving. So we can just go ahead and do the last step here, which will be simplifying this 4x and 3x together, because we can add them up together as they are the same terms. So therefore, this just becomes 7x plus 4 over 12. And this would be our answer for this example. So moving on, let's see, what's the third example? So the third example, say we have 3x over 4p square q plus 1 over 2pq. This example is slightly different. You see, the denominator is no longer just numbers, it's more complicated now. We have unknowns inside. So, how do we approach the question? You might be wondering. So, good question. And for that, we have to really look closely at the denominators. So, 4p square q and 2pq. If I took a moment and a pause and I think, if I multiplied this denominator by 2p, what do I get? I would have gotten 4p square q, correct? And that is what we have to really understand. We have to be able to look at this and see that if I multiply this by 2p, I would get the same denominator. So in a way, I can just keep this term here the same and really just focus on this part here as the first step. So this gives me plus, I'm going to times 2p on top and times 2p below. This gives me 2p over 4p square cubed. Okay, And then I just need to add them up because the denominators are now the same. So this lets us close off with this simple step. So we go about adding them up and we get 3x plus 2p over 4p square q. And that would simply be the final answer for this example again. So let me move on to the fourth example now. The fourth example, we have 3 over 2x plus 1 plus 4x over x plus 1. Okay. So straight away I'm going to say that the question is actually being a bit kind to us. Because right now, they have made it such a way where it's obvious that x plus 1 here are the same. They could have also done this, and the question would be slightly more tricky, you see. If they posed the question as such, it would have been more tricky because you would have to see that I can actually factorize the 2 out here and still get x plus 1. Okay, so in this case, the question is being quite kind. So let's say it's being quite kind, we know that this and this are the same, so we know simply that to get the same denominator, we have to multiply this side by 2. That's about it. Because you can see clearly x plus 1 and x plus 1 here. So therefore, keep this left term the same and proceed to change the right hand term to the same denominator. So this will be this. And now we have multiplying by 2, right? So 4x times 2 gives me 8x. And x plus 1, the whole thing, multiplied by 2, gives me. Therefore, now we have the same denominator. I'm just going to go ahead straight away and add them up. And let's see what we get. We get 8x plus 3 over 2x plus 1. Is there any more things I can factorize? Can I factorize this in such a way where I have x plus 1 as the term, as a remainder? I cannot, right? So, this will just be the answer. If for example, right, if for example this was instead of 8x plus 3, it was 8x plus 8, I would be able to factorize out on 8, and this will be just x plus 1, correct? If it was actually 8x plus 8, I'll be able to cancel out x plus 1 here and x plus 1 here, and just get the answer of 8 over 2. 8 over 2 will just give me 4. So that was something interesting to take note if, let's say, the question was slightly different. Okay, but in this case, this answer is fine and we should just stop here. This will be the final answer. Okay, now on to my last example. So my last example, I'm going to make it slightly more challenging. Okay, so say we have 4x over x plus 1 and 3 minus x. This is added to 3 over x plus 1 and x minus 3. Okay, so now what happens? I'm going to compare the denominator once again. Always when we have these types of questions, we compare the denominator. We see that this and these are the same, but this and this are different. So they're slightly different. What can we do? You need to think about it here and realize that if I actually put out a negative 1 from this part here, it would be pretty similar. What do I mean? Let's say, right, we write this as such. Okay, then we ask ourselves, is this mathematically sound? Pull out negative 1, and if I were to add it in, would I get back to our original? Let's check it out. So minus 1 times x give me minus x, and minus 1 times 3 give me positive 3. So yes, it checks out. So this is correct. It's an okay step to do. So now again, we look at two denominators and we see that they are different, right? This one is extra negative 1. So let's just go ahead and introduce a negative 1 here. So introducing a negative 1, I can say maybe I'm going to multiply the top and the bottom by negative 1. right? So what will this give me? Let me do that now. This just gives me let me rewrite this. Okay, so it will give me plus -3, right? Because I'm multiplying -1 on top and the bottom. And this becomes -1 x plus 1 x minus 3. Okay. So, and it's true because both of them have negative signs here, right? So they would also be equals to this, because both of the negative signs would be cancelling each other out. So therefore, it's fine. We can now just go ahead and sum the two numerators and we will be getting our answer already. So now it's just simple as such. This will be the last and final step. We're going to say this is equals to 4x plus a -3, so this will become -3, and the denominator will just be -1 x plus 1 x minus 3. And with that, we've gotten our final answer. Why? Because over here, we can't factorize anything out where we'll have the remainder being either x plus 1 or x minus 3. And that's about it. So therefore, this will be our final answer. I hope that you enjoyed and learned something from this video. And as always, please like and subscribe. Thank you very much.